All right, so we are going to talk about molecules and compounds. So a molecule is what happens when you have two or more atoms that bond together. Okay, so we have some examples down here. We have methane, water, carbon dioxide, ethine, and sulfuric acid. Now, each of these colored circles is an atom. So over here we have our key. The blue ones are hydrogen, green are oxygen, red are carbon, orange are sulfur. So for this first one, methane, we have one carbon and four hydrogens bonded together. Okay, so these sticks right here, those represent the bond. So hydrogens are bonded to the carbon. Notice that hydrogens are not bonded to each other. They're just bonded to the carbon. Here we have water. We have oxygen in the middle, hydrogens on the outside, hydrogens bonded to the oxygens. Here we have carbon dioxide, carbon in the middle, two oxygens on the outside, ethine, two carbons in the middle, two hydrogens on the outside, sulfuric acid, one sulfur in the middle, that's the orange one, four oxygens on the outside, and two of those oxygens have a hydrogen attached to them. So these are just examples of different possible molecules. Okay, again, molecules are what happens when you have two or more atoms that are bonded together. Okay, now a compound is when you get several molecules kind of bunched up together. Now, not when they're bonded together, but let's say you have a glass of water. Okay, now a glass of water has a whole bunch of water molecules all put in the same place. Okay, they're not bonded together, they're just put in the same place. So that means you have a compound. Okay, so molecules are the building blocks of compounds. Okay, and atoms are the building blocks of molecules. All right, now, every atom has at least one energy level. Okay, and there are multiple energy levels for certain atoms. Okay, so there are up to 7 possible energy levels. We're really only going to talk about the first 4. Okay, the first energy level can hold 2 electrons. The second energy level can hold 8. Third can hold 18. Fourth can hold 32. This is kind of a simplified version of that. So the way that it works is that's how many the maximum amount of electrons can fit in each energy level. But the outermost electrons in the outermost energy level are called the valence electrons. Okay, now the valence electrons are really, really important. They determine the chemical properties and the stability of the atom. Okay, they're also what electrons actually are involved in chemical reactions. Okay, which kind of makes sense when you think about it, right? Valence electrons are again the electrons that are on the outermost part of the electron, the furthest away from the nucleus. So when an atom interacts with another atom, the thing that's actually interacting is the outermost electrons. Okay, the electrons that are furthest away from the nucleus are interacting with the other electrons that are furthest away from the nucleus from the other atom. Okay, so that's what valence electrons are. Now, valence or atoms follow what's called the octet rule. Okay, the octet rule says that atoms will gain, lose, or share electrons to have a full valence shell. So all atoms want to have 8 valence electrons. That's like a magic number. That's really important. Okay, so since atoms want to have 8 valence electrons, they can gain or lose or share electrons to get that 8. And that's how chemical reactions work. Okay, that's why chemical reactions happen, is so that atoms can get their 8 valence electrons. So, for example, let's say we have an atom and it has 7 valence electrons. It's not happy. It wants 8. It has 7. That's bad. So it's going to try to find one extra electron somewhere and snatch it up and put it into its valence shell. So now it'll have 8 valence electrons. Now, you may be asking, well, why would you lose an electron? Because you're not getting closer to 8, right? Okay, so let's look at this again. And let's pretend this outer shell here only has 1 valence electron. Okay, well, you think, well, 1, you want to get 8, right? So you add 7. But that's not the way it works. The way it works is if this only has 1 valence electron on the outside, it would get rid of that valence electron, right? So if it gets rid of that valence electron, this outer shell would then be empty, which means it wouldn't exist anymore. So that would mean that this green shell is now the outermost electron shell. And it has 8 valence electrons on it. So that's the reason that that atoms lose electrons sometimes, is because, they want 8. And if it only has 1 or 2 or a small number, then it'll get rid of those 1 or 2 or whatever. And then the next most outer electron shell will be its new valence shell. So it'll have 8. Okay. And when atoms have 8 valence electrons, they are happy. They're stable. They're good to go. Okay. All right. Now, on the periodic table, we have rows. Those are called periods. Now, very important, rows are the horizontal ones. So going back and forth like this. Okay. Columns are the up and down ones. So going up and down like this. So real quick, we're going to switch to this periodic table. So this, where it says 4 right here, this is a period or a row. So every element in this row is part of the 4th period. Now, columns, again, are up and down. So this is a column. Every element in this column is part of that family or group. Okay. Now, valence electrons are generally determined by the group number. So this group here, that has 1 valence electron. Every atom in this group has 1 valence electron. This is group 2. Every element in this group has 2 valence electrons. Okay. Now, these ones in here, these are a little bit different. So when we're counting columns and counting valence electrons, we just skip these because there's no way to tell how many valence electrons each of these has based on where it is on the periodic table. So we're going to go from group 2 here, skip these down here, and then go here, and we're going to call that group 3. So group 3 all has 3 valence electrons. Group 4 has 4 valence electrons. 5 has 5 valence electrons. 6 has 6 valence electrons. 7 has 7 valence electrons. And group 8 has 8 valence electrons. Okay, so that is how that works. All right, now, the periods correspond to the energy levels used by the electrons, generally. Okay. And the groups correspond, like I said, to the number of valence electrons. Now, remember those exceptions I was just talking about, the ones in the middle, the big chunk in the middle, those don't count for valence electrons. Okay. Now, this will also help to figure out ion charges, which we'll talk about. All right. Now, we have, cations and anions on the periodic table. Now, a cation is a positive ion. An anion is a negative ion. Okay. Now, generally, metals produce cations. So they're the left and bottom of the periodic table. So again, I'm going to go back to here. So all of these are metals. Okay, so the thing that separates metals is this line right here. So over, down, over, down, over, down, and it's just a staircase that starts right under boron and right above aluminum and goes over one, down one, all the way to the edge of the periodic table. Anything to the left of that staircase is a metal, and generally, not 100% of the time, but generally forms a cation or a positive ion. Anything to the right of that staircase is a nonmetal, and again, generally forms an anion or negative ion. All right, and then there's the metalloids and semimetals, and they are right on that staircase. So real quick, I'll go back to that again. So anything that's directly on the staircase, touching the staircase, so all these like kind of off green color, like forest green colored ones, those are metalloids. Okay, so they have properties of both metals and nonmetals. There we go. Actually, what slide are we on right now? Okay. All right, so next we have valence dot diagrams. Okay, now when you're writing dot diagrams, okay, the way that you do that is first you just find the symbol of what you're writing. So like if we're doing sodium, okay, we would write Na right in the middle there. Okay, then we determine how many valence electrons sodium has. Now, sodium in this modified periodic table we can find right here. It is in the very first column of the periodic table. So that means it has one valence electron. Okay. Now, since it only has one valence electron, that's real easy. All we have to do is just draw one dot on one of the sides of the Na, just like we have right here. Since it has one valence electron, that dot right there represents that one valence electron. Okay. So however many dots we have, however many valence electrons we have, that is how many dots we need to put around the symbol. Okay. So over here we have chlorine. So here we have chlorine. Chlorine is right here. That is in the 7th column of the periodic table. So that means it has 7 valence electrons. Okay, so that's why we have 1, 2, 3, 4, 5, 6, 7 dots around the chlorine symbol. Okay, now last thing, we can only have 2 dots per side with a maximum of 8 total dots. Okay, so if we took these 2 dots over here and put them on this side and left this side blank, that is bad. We don't want to do that. Okay, there are only 2 here, 2 here, 2 here, and 1 here. We can't have any more than 2 per side. Okay. Okay, that is all for this.